Hello, everyone, and thank you for joining us for this morning for week 5 of the RISE Institute and Rugby Research and Injury Prevention Group 2026 Sports Science Series. We will begin our first sports science presentation. Our first intern is Angelica, and she will be presenting on high carb endurance fueling. Angelica, please share your screen.
Good morning, everyone. My name is Angelica. I'm a senior majoring in health science at Stony Brook University, and I will share my screen. So good morning, everyone. Today, I'll be presenting on an article entitled The Impact of High Carbohydrate, Low Fat versus Low Carbohydrate Diet on Performance and Body Composition in Physically Active Adults, a crossover controlled trial. So first, to get a little bit into the background, carbohydrates are the body's primary source of energy, which a lot of us know. During moderate to high intensity exercise, while low carbohydrate diets have become increasingly popular for weight management and overall health. On the right, I inserted an image of what a low-fat, high-carb diet may look like and what a low-carb, high-fat diet looks like. So, for example, on the top, you can see processed seed oils, sugary fruit, and limited dairy, while on the bottom, you could see full-fat dairy, foods like avocados, salmon, things of that sort. However, there's still a debate about which diet better supports athletic performance. The purpose of this study was basically to compare a high carbohydrate, low fat diet with a low carbohydrate diet and determine their effects on exercise performance, body composition, and blood lipid levels. Moving on to the methods, how this was executed. So this was a crossover control trial involving 24 physically active adults with 18 participants completing the dietary intervention and 6 serving as controls. In simple, if you don't know what a crossover study is, a crossover study is basically one group of people undergoing multiple treatments in a randomized sequence and serving as their own controls. And this basically helps to reduce variability between subjects. So each participant followed both diets for 3 weeks, separated by a 3-week washout period, which is basically resuming back to their regular lifestyle, not being on a specific diet. And because these participants completed both diets, they served as their own control, reducing differences between individuals, like I had mentioned. And on the right is just a timeline of what each participant went through if they weren't in that control group. Moving on to the measurements, researchers measured several outcomes before and after each diet. Performance was assessed using VO2 peak cycling power, and time exhaustion during exercise testing. If you're not sure what the VO2 peak is, it's basically described as the maximum amount of oxygen your body can use during intense exercise. So that was measured to help come to a conclusion. They also evaluated body composition, including body weight, body fat percentage, lean body mass, and skeletal muscle mass. And finally, blood samples were collected to measure cholesterol and triglyceride levels in order to assess the metabolic effects of each diet. And on the right, here's kind of like a setup of what that experiment would look like to measure everything. On to the results of the performance. The high carbohydrate diet produced better exercise performance, including a higher peak power output and a longer time to exhaustion compared to the low carbohydrate diet. The low carb diet had a similar VO2 peak in comparison to the high carb diet. On the other hand, the low carb diet had a lower peak performance compared to the high carb diet. So, therefore, this study concluded that the high carb intake produced better short-term exercise performance. Moving on to the body composition and blood markers. Both diets resulted in reductions in body weight and body fat, which was a big plus, while lean body mass remained relatively unchanged in both. In terms of blood lipids, the high carbohydrate diet lowered total and LDL cholesterol, but was associated with higher triglyceride levels, which was a downside. As you can see on the table on the right, extracted directly from the article, both diets resulted in improvements in body composition over the 3-week intervention overall. Participants lost about 1.3 to 1.4 kilograms of body weight and reduced their body fat by approximately 1.4 to 1.7%, while the lean body mass and skeletal muscle remained relatively unchanged for both. Moving on to the conclusions. Overall, the study concluded that while both diets helped improve body composition, the high carb diet was more effective at supporting exercise performance. These findings suggest that athletes participating in moderate or high intensity activities may benefit more from a high carb diet, whereas dietary recommendations should still be individualized based on an athlete's specific goals and health needs. So at times when an athlete may be trying to cut down on their weight, a low carb diet may be better for them. But if they're trying to compete at a higher level, the carbs are needed to help their body produce that energy and to recover as well. Onto the strengths and limitations. One strength of the study is it's a crossover design, like I mentioned, which allowed each participant to experience both diets and it reduced individual variability. The researchers also evaluated multiple outcomes, including the performance, body composition, and blood markers, which was also a great thing. However, the study had several limitations. The sample size was relatively small, and the intervention lasted only 3 weeks for each diet. So if it was more long term and if there were more participants, it would be a lot more reliable. And the participants were young, healthy adults, limiting how well the results may apply to other populations. So maybe they could have included adults that weren't as active as well to make the results more generalizable. Here's the reference I used if you're interested. Thank you everyone for your time. And
That
I'm open
was,
to it.
oh, sorry.
Sorry.
That was an excellent presentation, Angelica. If anyone has any questions, you can ask them now. If not, oh, Hunter.
Sorry, I couldn't find the raise hand button. Um, but I was wondering whether they regulated the specific items and how they were getting these carbohydrates or fats, because in some ways, you could be for the high fat, low carb diet, you could be having a lot of fried foods, or you could be also getting it from more healthy fats like salmon or maybe steaks and that kind of thing. So did they have any place any regulations on how you could achieve these levels, and also what was considered low carb, high fat, or high carb, low fat?
Yes, so what they actually did during the study was they set a percentage of what would be considered like a low carb diet versus what would be considered a high carb diet. I believe it said on average Americans consume like about 44% of a carb diet, while the low carb diet was about 16%. So that was one thing that was very shocking to me. But basically they they set like kind of like a threshold and said the low carb diet would consist of 16% carbs for each participant.
And then what about like the uh source of the fat? So whether it was super processed foods or like healthier salmon.
I believe they did stick with the healthier side. I think one of the somewhere where I could have improved on this presentation was maybe include images of what they actually included, because it does come off that, the high carb diet might have been consisted of only like the processed foods, but they did use more whole foods for the experiment.
Okay, thank you. That answers my question.
Does
I
anyone else have any questions?
I was also going to ask a question. I know you mentioned that they used healthy young adults for this study, but I was wondering if there was any part of it that specified different outcomes depending on, if women or men. And, I know that the bodies have different needs. So I was just wondering if, you had any insight regarding that.
Yeah, so basically the way they had screened to see if an adult was truly healthy enough for their experiment was they basically wanted to know how active they were in their daily lives. And they also used their BMI as well to basically determine if they were healthy enough for this experiment. In terms of variation between men and women, they didn't give much insight on that. But in terms of the screening for the healthy adults, they did use, kind of like subjective information, but also like information they could have extracted from the patient itself.
Thank you so much, Angelica. Dr. Lopez, do you have any questions or anything to add?
No, I thought it was an interesting topic. Thank you so much, Angelica. I guess, um, you know, Hunter brought up the concern I had was, did they regulate what they consumed? I know they attempted to, I guess, I don't know if you know that they have like AI imagery to figure out caloric intake. You can take pictures of your food and it actually kind of gives you an idea. How did they measure the caloric intake? Did they use imagery? Did they use uh, weight based? Did they actually put in the topic? Oh, I ate steak today at 4 ounces.
So from what I know, they definitely didn't use that newer technology that many of us may use to track our calories, our intake. I don't believe it mentioned how they recorded that data. I think it might have just been self-recorded.
Hmm. Okay. Listen, there's different ways to achieving that information. I just wanted to see if they did employ some of that newer tech. I don't know if everyone knows what we're talking about here, but maybe Angelica, anyone know about it? You want to try to give us a stab at? Yeah, go ahead. Let's see. Good. Someone, Hunter, let's have a debate here.
Yeah.
Talk.
So I have seen a couple of videos about these. It's been a while since I've kind of looked into the topic, but one concern that they did when reviewing these AI models when taking photos is that when you like kind of put it on a plate, you can't really, especially when all the different ingredients are layered, you can't really tell what the actual volume is on the plate. So you could have like chicken, but there might underneath it there might be rice, which I would miss, and then also. I feel like typically when I see calorie tracking, I'll see it in the form of taking the food either raw or cooked and then putting on a scale to get more accurate measurements of and basing it off reputable databases to see how calories are tracked. But that's kind of why I have a little bit of skepticism towards AI and just using photos.
No, thank you so much, Hunter. Very good job. Now, I guess that's exactly what I was going to allude to. It almost has to be like a TV dinner, you know, peas and, isolated, potatoes isolated, and then whatever your meat. Now, the thing is, you also don't know what the depth is. I think the AI, I think one software allows you to do the depth with the AI imagery. So therefore it creates like a volume. But again, we all know, right, from basic geometry, calculating volume is challenging with maybe spherical peas or coined carrots. Go ahead, Jordan, talk to me.
Well, I was also gonna say a bunch of the marketing for these websites, it like costs money for a lot of them to scan your food. So I think a lot of times they can miscalculate how many calories something is to make you feel like you're losing more weight on your journey or something like that, and that their app is helping you lose weight, which is faulty and not good at all.
Right. So there are limitations in the software. Go ahead, Hunter. Don't worry, just open up your mic.
Yeah. And then one more thing that I want to mention is that one of the problems with self-reporting, especially in a study like this, is that it's easy to forget about the small things you have. So maybe like a barbecue sauce or like a drink that you have on the side, and those also have calories even. And then every day when you have them with every single meal, it's kind of adds up and leads to, I guess.
Correct. Condiments are very, very unique. I think um anyone seen the movie Pulp Fiction? Right? Right. What do they say the difference between a burger overseas, in Europe? Anyway, the whole idea is that they're very big into the mayo. Meanwhile, we're big into the ketchup. The condiments are surprisingly caloric, a challenge to measure, to quantitate, and also use in diets. And so people really use it. What I did was I moved to mustards. Then I started dabbling in all the like different types of mustards. They do have a little bit more caloric intake, but there's a little bit more fiber. They're a little bit less caloric, sugar based. So there's a little bit benefit to it, but I do love my condiments as well. But you have to kind of choose your battles of what you're going to consume. But anyway, I really appreciate everyone talking about that, and not only that, but the software. Like I said, it doesn't take into count many things, and it gives you an idea. It does help, and people who are digital dependent love using these things. They love using their phones. They maybe employ them in many parts. Again, honestly, I probably only use 10% of my phone's capabilities, right? In regards to what's employed, what I use it for. I actually avoid putting apps on my phone because I wanted to focus on what I really need it for. So anyway, the point is these apps do have limitations. And if this study, Angelica, based its caloric intake by the actual person consuming, as Hunter alluded to, did they look at it post cooked or pre cooked? Post cooked, you lose hydration, water weight. This is why the George Foreman grill worked so well. Laugh all you want. I used my my George Foreman grill like literally for like 15, 20 years until it finally broke. I had probably one of the first generation ones. Some of the stuff, but it worked because it, got rid of all the fat, right? When you cook it in the idea is to, yes, desaturate, maybe to take out fat and water at the same time, or it uses the water to take out the fat. And by cooking it on that George Foreman grill, you release or get rid of the fat. So there's benefits in how I don't think the study looked at how they prepare the meats or anything, right? So this is what I'm talking about. You could have also decreased the intake. Yes, maybe looked at the protein, but then you have how much fat was lost, because you can actually measure that. You can actually put it in a cup, let it harden, and weigh it if you wanted to, right? You've seen fat. What is it called when fat gets hard? Anyone know? Congeals, coalesces, which one is it? Come on, someone. So you can measure the weight of that. Look that up. So anyway, you get what I mean? There's a way of really, and honestly, I think they did a nutritional study, and I want to say it was out of Hong Kong, and they did something crazy like that. I think they built upon everything. They measured it down to the milligram. But again, right? Isabella, we were talking about the other day. That's the idea. That's under like laboratory. They took their athletes, their I think it was like half marathon runners, and they evaluated their caloric consumptions, right? Because everyone knows, what do they do? What do the runners do before, or what do the running entities do before a major marathon? Anyone? Come on, try. Dad, take a stab at it. What do they offer? Anyone know?
Is it like tapering? Like
No,
for
no, no.
oh,
So let's say the New York Marathon Runners Club, or the New York whatever Runners Club, they get everyone together the night before for what?
Carb loading?
Yeah, a lot of
Yeah, there you
like
go, Hunter.
pasta dinner
The
situation.
big pasta dinner, right? The carb loading. Does anyone know what I'm talking about here? Has anyone seen it? So look it up. What they do is they do that. I do think um I don't know if they still do it in the Tour de France, and then the Spanish Tour. So I used to bike a lot, and back in the day, obviously, you're in Spain, right? You bike. Everyone bikes. Like everyone aspires to be in the Tour de France. So you're like biking everywhere, on the plateaus, up the hills, everywhere, from little town to little town. It's just phenomenal to do that kind of loop. So and the highways are just phenomenal for that. They're made for that. It's beautiful. But also it's because they got less people. So it's just the way it is. So the whole idea, the carb loading, they they did these half marathoners, and they evaluated, what they ate for the week, what they, desaturated, what, like, how did they, they weighed the fat in a cup, they made them pour all the fats for the week into one cup, weigh it. I don't know how you take a steak and evaluate what the caloric intake of it post cooking. There's a way, like I said, they really did this crazy study, but it can be done. So there's limitations in this study, but obviously they tried to show what you can gain out of the food intake from this. There are benefits in carb loading and carbohydrate intake, and obviously there's a reason it's still done in marathons today. That's basically what I'm trying to tell you. You need that peak for endurance to outlast fatigue, right? And then they have on the course, and for triathlon, for biking, they have the concentrated carb packets, right? You guys know what I'm talking about now. So you can still try to keep that up, but there's no way of who's what using it. And they've moved away from trying to regulate all that because it's just impractical, right? Because there's just the amount of burn, the amount of caloric usage in marathon running, triathlon, bike touring, you just that's just crazy. Like you're just burning so many, so you can't really regulate, dietary restrictions on the course, right? You got people, teams restocking them with those sugar packets, the concentrated carbs, you know. So it's allowed in sport in some capacity because obviously the sport demands it, right? They're just burning. You're like, didn't we discuss like, so what's the Olympian from Norway in the biathlon? What's his drink of choice? Anyone remember? Did I bring it up with this class? Sorry. So, who does anyone know what the biathlon is? What is it? Hunter? What is it?
I believe it's one of it's a sport sanctioned by the IOC, but it's a cross country skiing, and then there's also shooting as well.
Because of the fatigue, right? So, focus on shooting, and then the cross country skiing. But now, now it's uphill, downhill. It's legit. So, what's his drink of choice? You think it's Gatorade? Coca-Cola. Because of the caffeine and the concentration of sugar. So his choice is interesting, and that's what I used as compared to coffee while I was studying in med school. Whatever works, right? The caffeine was giving me too much irritation to the stomach, so I moved to Coca-Cola. I mean, don't get me wrong, you're still gonna get heartburn, and you're still gonna, you're dealing with trying to, you know, compete for an endurance sport of medical school. All right. Anyway, interesting nonetheless, right? All right, everyone. Thanks a lot, Angelica. Great debate on everyone to bring that all in there. All right.
Thank you so much, Angelica, for your presentation. Our next presenter is Elena, who will be presenting on ketogenic diets for high-intensity athletes. Elena, you can share your screen and introduce yourself. Thank you.
For the introduction, my name is Elena, and I'm an incoming junior at UVA. And I also just sent a request to. Is everyone able to see my screen? Today I'll be presenting on ketogenic, low carbohydrate, high fat diet, the future of elite endurance sport. This is a 2021 review by Louise Burke that was published in the Journal of Physiology. So endurance sports are defined as continuous events that last more than 30 minutes, with anything past 4 to 5 hours considered ultra endurance. These events depend on oxygen-driven ATP production, which requires two things: enough oxygen delivery to the muscle and enough fuel, which includes carbohydrates and fats, to burn. For around the past 60 years, sports nutrition guidance has centered almost entirely on carbohydrate availability, which includes loading carbs before a race and taking in carbs during the event. And these are all to keep carbohydrate oxidation high throughout exercise. Since 2012, ketogenic, low carb, high fat diets, or KLCHF for short, have gained a lot of traction both in the scientific literature and in social media. The claim is that this diet unlocks a much greater capacity to burn fat during exercise. Just to define a KLCHF diet for this study, this means that under 5% of the daily energy will come from carbs, which is less than 50 grams a day, with 15 to 20% of the energy coming from protein and 75 to 80% from fat. This keeps blood ketones elevated to above 0.5 millimoles per liter. So this review directly pushes back on the claim that LCHF diets are the future of elite endurance sport. Burke frames this analysis around 3 questions. First, performance transfer. Does that extra fat oxidation capacity actually translate into faster race times? Second, time course. How long does keto adaptation actually take to happen? And third, periodization. Could cycling KLCHF with high carb blocks give athletes the best of both worlds? So Burke conducted a literature review built from a systematic search of published research and cross-checked reference lists for anything missed. She did include some of her own unpublished data from her lab. And importantly, studies were only included if the athlete's KLCHF adherence was verified, whether through blood or urine ketone testing, and if they were actively engaged in endurance training or competition. He also defines 4 diet categories used throughout the review. HCHO is high carbohydrate availability. PCHO is periodized carb availability. And KLCHF is non-ketogenic, low carb, high fat. And KLCHF is true ketogenic, low carb. So as for performance transfer, Burke looked at elite race walkers, and the high carb group was compared to their baseline 1,000 meter time, and their time improved by 6.6%, while the KLCHF group was 1.6% slower, even though their fat oxidation rates increased to 1.5 grams per minute. A replication study in 2020 found almost the identical result. High carb improved their time by 4.8%, and the participants on the KLCHF diet 2.3% worse. In trained runners and triathletes, there was no significant difference in the average time to exhaustion, but the KLCHF group showed worse exercise economy and a lot more variability between individuals. A 12-week study in trained endurance athletes found no significant difference in a 100-kilometer time trial. However, a large share of the KLCHF group could not stick with the diet long enough to finish. In recreational runners doing 5-kilometer time trials, there was no significant difference after 14 to 42 days of adaptation. So the consistent theme here is that fat oxidation did increase on the KLCHF diet. The racing did not follow. In terms of the time course of adaptation, fat oxidation changes very quickly. Substantial increases show up within only 5 to 10 days, and the effect maxes out by 3 to 4 weeks. The peak rates of fat oxidation were around 1.5 grams per minute, which is roughly 200 to 250% higher than that on a carb diet. The intensity where the maximum fat burning occurred also shifts from around 45% up to 70% of the VO2 peak. On well-being, the keto flu occurred, which is a short onset of symptoms including fatigue, irritability, and reduced training quality. This is common in the first 7 to 10 days, but training capacity is typically restored within 2 to 3 weeks in well-trained athletes. Carbohydrate metabolism did not fully normalize. The muscle glycogen stores dropped, do not disappear. There was about a 47% reduction after 4 weeks of severe restriction. Whether long-term adaptation, which would occur over months, fully restores glycogen use is still unresolved. And lastly, in terms of periodization, Burke tested 3 periodization models to see if combining this diet with strategic carb use could capture benefits from both. So model 1, LCHF diets during training, then high carb before racing. The idea was that the keto adaptation could carry over, similar to altitude training, once carbs are restored for the race. This was tested in elite race walkers, and there was no extra benefit over just doing high carb training the whole time. Model 2 was chronic KLCHF and acute carb loading before the race. 1 day of carb loading after keto adaptation did not fully restore carbohydrate oxidation, and the performance was still worse in the high carb group. 6 out of the 7 athletes actually got slower. And in Model 3, KLCHF was cycled with strategic carb intake during key sessions. This was only a single case study of 1 elite triathlete, and this did show small improvements. However, it is very limited since only 1 athlete was studied. So what explains this disconnect between improved fat oxidation and unchanged or even worse performance? So fat oxidation goes up substantially with this diet, even in elite athletes who are already well-trained fat burners. However, that metabolic shift does not show up at race times. The likely explanation for this is reduced exercise economy, as burning fat costs more oxygen per unit of ATP than burning carbohydrates does. So at the same pace, a fat-adapted athlete is working harder physiologically, even if it doesn't feel that way to them. Also, keto adaptation seems to blunt the muscle's ability to use whatever glycogen it still has. This is particularly costly at higher intensities because oxygen becomes the limiting factor and carbohydrate becomes the more valuable fuel. Also, individual response varies a lot. Athletes tolerate this diet fine, some get worse, and some cannot even finish the study that they are a part of. There are a few limitations in this study. So these studies are very variable in terms of athlete caliber, their adaptation length, and testing protocol. A lot of free living studies had dropout problems. About 14 of the subjects in one of the studies looked at did not finish. Also, substrate oxidation in most of these studies is estimated from breathing gases, and this is not very accurate at high exercise intensity because of how the body buffers acid production. So CO2 that is released can buffer hydrogen ions, which would cause oxidation to be underestimated and carbohydrates to be overestimated. There is also no solid data beyond 12 weeks, so any claims about long-term adaptation mostly comes from comparing separate groups of already adapted athletes rather than tracking the same people over time. And the author also did run some of the key studies that were analyzed, but this was disclosed. So in conclusion, KLCHF diets do reliably increase fat burning capacity. However, this does not reliably translate into faster racing. For high intensity performance, there's worse energy economy and impaired glycogen use, which makes it a poor fit when the intensity is above 80% of a person's VO2 peak. Adaptation does happen very quickly, from 5 to 10 days to 3 to 4 weeks, and staying on the diet longer does not appear to buy any additional benefits. And finally, the response is highly individual, so athletes considering this diet should weigh it against the specific demands of their event. And this is my reference if anyone would like to further look into the article. Thank you.
Thank you so much for your presentation. Are there any questions or anything that Dr. Lopez would like to comment on or
Well,
ask?
obviously a great transition, obviously with the carb loading from that we discussed just in the previous presentation. But here, the ketogenic diet, increasing the fat burning aspect, let's first take the number one probably thing we should think about, right? 45 VO2, 45% to 70%. We're taking them very, good, high, efficient endurance athlete, but then you're taking that 45 to 70, that's a big jump because then you're talking about your high endurance athletes. So you need to kind of remember that's that little window that they're talking about when they're discussing these athletes. I guess Elena, why don't you comment on that briefly before we proceed of how that they're talking about 45% VO2 to 70. It doesn't seem like it's a big jump, but that's a very big jump in performance.
Yeah, so 45% is, I think they noted it as like an optimal zone for like fat burning. But 80%, it's a lot higher of an intensity. So your body has to rely on carbohydrates because like it takes less energy to oxidize them and it's a quicker it's
Right.
just like more beneficial.
And you do need fat. You do need fat at that point because obviously when you're going from aerobic to anaerobic at that point, you wanna buffer it before you go into the anaerobic stage. Does everyone understand what we're talking about here in high endurance performance? Right, you burn a certain amount in your aerobic, but fat is almost protective. That's a bit, Elena, why don't you elaborate a little bit on that? What you read on there?
So I think that if the body runs out of carbohydrates at a higher intensity, then it kind of switches back to fat. So that's also like when they're not eating enough carbohydrates, then the body relies on more fat.
So when we when you look at this study, and again, great job, Elena, presenting this study. Obviously, trying to dilute the facts to a digestible understanding. I think I want everyone to understand where we're talking about. We're talking about, yeah, you're burning at 45, 40, 45 VO2 max, but I want you to interpret it as also a gauge to evaluate that you're talking about excellent fitness to elite endurance athlete levels, right? We're talking about, from maybe a rugby player as an elite to almost a marathoner where they're running for hours, right? So in rugby sevens, yeah, you have to be elite, but you're probably, getting up there in the 50s, 45, 50s for, similar to basketball. But these marathoners, those are the guys that are doing, the Kenyans who are doing, those marathons in 2 hours flat, it's like crazy. You cannot even get to the pace of them and let alone the zone that they're in. So the whole idea is that when you're looking at this study, and again, another great, like I said, when they start doing these details, yes, the author did disclose he did a lot of the basic foundational work and a lot of the studies he had done himself, but the thing is, it's another great study to add to this that they've actually, what do I say all the time? Replicated, they can replicate the study from 217 to 220, right? That it found similar from the 10,000, right? Am I correct? Correct me if I'm wrong. I'm just gonna, so they did the study in 2017, then they replicated the study in 2020. Did they do it still at the 10,000 meter?
Yeah, and they got
Or
like
they
exactly the same results.
to replicate your study, but then now they're building upon that work. So it's interesting to see that they did that. And like I said, um, the Model 3 limitations, it did show potential. Maybe if you can hone that in, Elena, maybe if you'd be so kind to like say, so in the Model 3, if everyone recalls, there was some limited benefits. Maybe kind of just talk about that, and so this way everyone understands again one more time so you could take the take home point.
Yeah, so in Model 3, it was a ketogenic diet and then strategic carb intake during the training sessions where they were training particularly heavily. So this was limited because it was only one athlete, but there were small improvements in like the high intensity efforts when carbs were added during other um, like similar high intensity exercises.
So what does that remind you of, everyone? What did we just discuss in the previous conclusion discussion? Good, Jack. Good. Don't worry. Just talk. Let's.
Carb loading before exercising.
No, no. What are the bicyclists on tour get? Or what are
The gels,
triathlon? Go ahead.
the gels.
Right. So they're allowed, you want that sugar blast to maybe restart. What aspects are we talking about? Mr. Julian from biochemistry? And what aspect are we talking about in the Krebs cycle? So when you put the sugar back in, right, that's why they say, oh, it's always great to, consume something that's going to go directly into the Krebs cycle, right? So this way your mitochondria are like blasting out ADP. And basically you're now throwing in the sugar right into it, right? That's why, you see people plowing down bananas all the time. Or now we've discussed they've come down to the science of it with these gel packets. So that's why they kind of let it happen because, you know, everyone's physiology is a teeny bit different. But if you know when you need it and you need it, because we've seen some of these people collapse at the finish line or maybe feet away from the finish line. These marathon runners, and you feel so bad. They're crawling to get across the line, right? Let's avoid that. Why don't we just let them take some, sugar supplements? Let's make the sport a little safer. We don't have to let them get to that. We've probably moved away from that vision of what it looks like, right? And I don't know what the rates are, but there probably are less of that due to the fact of allowing them to consume carbs in the gel packets on the track now. And I think everyone here can agree. I don't know, competitive edge wise, I'm not going to touch that with 10-foot pole, but I'm going to say it's probably healthier for them than collapsing 5 feet from the finish line, right? Or maybe losing bowel control. That's horrible. So again, great study. I just thought I'd bring that, and we can tie that all in between the carb loading, obviously the benefits of the carb gel packets, use in endurance sport in some capacity. Maybe we should add Dr. Skiba on this one, huh? Anyway, very good. Very good, everyone. What else we have? Very
Thank
good
you.
there, Lena.
Thank you so much, Elena, for your presentation. Our third intern to present is Julia, and she will be presenting on common recovery mechanisms. Julia, if you could introduce yourself and share your screen. Thank you.
No pressure, Julia. Take it easy. We'll just, all right.
Thank you so much for introduction, Natalia. I will share my screen right now. This can everyone see my slides? Okay, I cannot see you guys, so I hope that's a yes. So hi
Yes,
everyone.
we can see it.
Perfect, thank you. Hi everyone, my name is Julia Salim. I am a rising senior at Drury University, and today I'm going to be talking about a paper, Physical Performance and Subjective Ratings After Soccer-Specific Exercise Simulation, Comparison of Natural Grass versus Artificial Turf by Mathieu Nedelec and colleagues. So why was this study done? So artificial turf has become common in professional soccer, yet many players report that it feels harder to play on. They often describe it as an increased physical effort and greater muscle soreness after matches. However, previous studies show that running demands and movement patterns are actually often similar between the natural grass turf and the artificial turf. And because of these conflicting observations, the researchers for this paper wanted to determine whether the playing surface actually influences fatigue and recovery after soccer-specific exercises. And the question, does artificial turf delay recovery, remains extremely relevant today. That's because during the current 2026 FIFA World Cup, FIFA required every single stadium, even the NFL stadiums that usually have artificial turf, to install natural grass or hybrid grass playing surface for the tournament. This decision directly reflects on the importance that elite soccer places on playing surface quality, although it does not necessarily mean that natural grass leads to better recovery after every single match. So, purpose and hypothesis. The purpose of this study was then to compare recovery after soccer-specific exercise on both natural grass and artificial turf. For that, the researchers had players complete exactly the same soccer-specific exercise on the two different surfaces. Because artificial turf is generally considered firmer and produces faster changes of direction, the researchers hypothesized that players would experience greater fatigue, more muscle damage, and slower recovery after exercising on artificial turf. Methods. This was a randomized crossover design, which is considered a strong study design because every player served as his own control. They had 12 professional male soccer players that were experienced on both surfaces as participants for this study. Each athlete completed the exact same 90-minute soccer-specific exercise simulation on both a natural grass and artificial turf, with several weeks separating these two sessions. The researchers measured several indicators of recovery, including jump performance, sprint performance, hamstring strength, muscle soreness, fatigue, and overall recovery ratings. These measurements were then collected before exercise, immediately afterwards, 24 hours later, and 48 hours later. Physical performance results. In this table, you guys can see the results of the athlete's physical performance. Sprint performance did not differ between natural grass and artificial turf throughout the recovery period, and counter movement jump performance was also very similar. The only significant differences were that squat jump performance recovered slightly better on natural grass after 48 hours, while hamstring strength showed a slightly larger decrease after natural grass rather than after the artificial turf. And although this difference reached statistical significance, their effect sizes were small, meaning that they were unlikely to represent major practical differences. Subjective recovery. In addition to measuring performance, the researchers asked players how they felt during the recovery period. They assessed fatigue, muscle soreness, stress, sleep quality, and perceived recovery using standardized rating scales. As expected, fatigue and soreness increased immediately after the exercise protocol, regardless of the surface. However, there were no meaningful differences between natural grass and artificial turf for any of the subjective measures. By 48 hours, most ratings had returned close to the baseline. This is an important finding because athletes, they often report that artificial turf feels more demanding. And in this study, however, they perceived that recovery was actually very similar after playing on either of the surfaces. Muscle soreness. You guys can see that this table is table 3 from the paper. And this table shows where players reported muscle soreness during recovery. Rather than measuring how severe the soreness was, the researchers recorded which muscle groups players identified as sore. The largest differences occurred in the hamstrings after 48 hours, where more players reported soreness following artificial turf. However, it's important to note that objective hamstring strength did not show greater impairment on artificial turf. This then illustrates an important concept in sports medicine, that is, how athletes feel does not necessarily always perfectly match objective measures of muscle function. Clinical takeaways. The most important takeaway from this study, I believe, was that artificial turf did not produce greater fatigue or slower recovery than natural grass in these professional soccer players. One factor that likely contributed to these findings is that the participants were already accustomed to training and competing on both surfaces. And because they were familiar with the artificial turf, they may have adapted to its physical demands. From a practical perspective, these results suggest that clinicians, coaches, and athletes may not need to modify recovery strategies solely because of a training session or a match that was played on artificial turf, or at least that is for athletes that are regularly training or playing on both surfaces. At the same time, it's important to remember that recovery is only one aspect of playing surface research. Factors such as injury risk, ball behavior, player comfort, and overall match quality are separate considerations. This is reflected also in elite soccer today. Although the study found similar recovery on both surfaces, as I said previously, FIFA still chose to use natural or hybrid grass pitches for the 2026 World Cup. And many professional players continue to express a preference for grass. You can see while they're practicing and training before their matches for the World Cup, they're testing the balls, they're testing how they should move in the different turf. And this just highlights decisions about playing surfaces and how it involves many factors beyond the short-term recovery alone. Limitations and conclusions. Like every study, this one has limitations. First, the sample size was relatively small and including only professional and male soccer players. Second, the exercise protocol simulated a match, but it didn't really include collisions or tackles, which are common in an actual competition. And finally, all players were already familiar with the artificial turf, so these findings may not apply to athletes who rarely play on that surface. So overall, the authors concluded that a single bout of soccer-specific exercise on artificial turf does not produce greater fatigue or delay recovery compared with natural grass in players accustomed to both surfaces. This was my reference. Thank you so much. Are there any questions?
Thank you so much, Julia. If anyone has any questions, they can ask now. If not, Dr. Lopez, if you have any thoughts or questions that you want to ask. Erin?
Yeah. Oh, wait, that was a great presentation, first of all. I just have a question because given the results of the study, like do players just say that artificial turf is more demanding because it's like a psychological factor, or are there other factors that come into play?
I believe that there is a psychological matter in a way that sometimes if you're not accustomed to it, or there is like the myth that an artificial turf is harder to play on, they will end up realizing that. But I feel like the biggest conclusion you can take from this study is that is a training aspect. So for players that that's also like a limitation of the study. They got players that are accustomed to both turfs, but probably the reason why they say it's demanding is because not necessarily every professional player or club or country, like if you think about the World Cup, they're like all over the world, players that play for different countries and different clubs, and they can play in different turfs, and they might not be as accustomed to playing on an artificial turf than in a grass turf. So they can end up having more of a demanding recovery afterwards, since they are different turfs and they are different to play on, and they do reflect on your body afterwards.
Thank you so much for that, Julia. Go ahead, Kevin.
Hi, Julia. Thanks for that presentation. It was really interesting. As a soccer player myself, I have seen the effects of natural grass and turf, especially when natural grass is not kept well. Um, but I actually have a question. I wanted to see clarification if there was actually any references to barefoot training in the article, because I understand, like, I have been told by many of my coaches personally that barefoot training does help in order to be able to adjust that difference between bare artificial grass and natural grass. So I just want to get your opinion on that and see if the article mentioned that.
Unfortunately, the article did not mention that, but I think that that's a really interesting concept. From a couple of things I've personally read, I also really like soccer, so my whole family plays. So I think I've seen a bunch of complaining and heard a lot of things, and I ended up researching a lot when it comes to the sport. I think that yes, the barefoot training can really do differentiate. I think the type of cleats and etc. Probably should change depending on the turf you're playing. That it's probably in any sport that uses cleats and different turfs. So probably barefoot training does has a factor in whether the recovery comes from the artificial turf or the natural grass. Unfortunately, the paper itself did not go in depth with strategies to also adapt and do better recovery. They were just trying to see if there is an effect on recovery or not. So they did not mention anything about the barefoot, but yeah, I don't know if that answers your question, but.
Jack.
Thanks for the great presentation, Julia. It was, I think it's a really interesting topic. I was wondering, I don't know if this is a part of the study, but I know like the researchers talked about, kind of like, I know they talked about like soreness and muscle fatigue and stuff, but did they talk about like actual like injury occurrences on the two, field types, and whether there was like more, like a higher probability of injuries on one or the other? Like I know myself personally, like I play lacrosse, and I definitely prefer to play like on a even surface, like turf, like, and not grass. Like I know grass a lot of times, especially when Kevin was saying when it's like unkept and it's uneven, like that caused me to get like hamstring strains and stuff like that. I was wondering, did it talk about injuries at all, or did they not really mention that in the study?
I remember that they were talking more about the necessarily the parts of the body or the muscle soreness they did end up seeing after the trials they did. Not necessarily if there were any injuries, because they were testing more on this, like on the asking the players on where they were sore or analyzing where they were sore, not necessarily if there could be an injury, if that makes sense. I don't know if, but
Yeah, that helps it. Thank you.
yeah, of course.
Hunter.
Hi, Julia. Thank you for that presentation. That was really, really well said. I have two questions for you. The first one is in relation to what Kevin and Jack were talking about. Did they have any restrictions on what type of fields they did this testing on? Was it like perfect FIFA level grass and perfect artificial turf? Because I know from speaking to a lot of players at these rugby tournaments, and I've asked the same question for some of our interviews. And some of them prefer grass and but also some of them prefer turf because it's more consistent. So what do you think about that?
Or did they play on FIFA approved turf or FIFA approved grass?
Yeah.
Because it has to be approved.
Yes. As I was reading, I don't remember them mentioning the FIFA approved, like necessarily, but they did mention, I believe when they say like a natural grass, they didn't necessarily just put them in like a grass field and said play. They probably did what I feel like they assumed would be like a natural grass where they have like a court and they have the natural grass as even as possible. They did not necessarily say it was FIFA approved, so maybe that would be something to look into, because I don't know what I'm saying. And do you have a second question, right?
Yeah, so that might be a limitation of the study with like the variability in a lot of fields. And then my second question would be, so I've done a little bit of a little bit of a literary search, and I've seen that there are articles about that have tracked the pressure on the plantar surface of the bottom of the sole of the foot on different artificial and grass surfaces, and they showed that sometimes in some parts of the foot, I don't remember which parts, there might be a little bit more pressure. Do you think that maybe the reason they don't see that translate to recovery issues is that, and this might be why that soccer players feel the surface is harder, that maybe artificial surfaces they have less shock absorption, but in the end it doesn't end up lead, so this would contribute to the player discomfort while playing, but would ultimately not have significant difference in recovery. Do you think that could be a possibility?
I do think that could be a possibility. I think, of course, when you play in two different types of turf that have different types of shock absorbance and different types of consequences when you play, your body takes a little bit harder to adapt. I feel like it's also a limitation in this study, particularly the fact that they got players that were accustomed to both. Maybe if you had players like player accustomed to both, player accustomed only to natural grass, player accustomed to, or not professional players, like maybe those impacts could be seen in a bigger scale, but unfortunately it was like 12 players that were accustomed to both. But I do think that the changing of the type of turf will directly impact if you're not accustomed to it, if you don't know how to play on it, if your body's not accustomed to it, especially when it comes to shock absorbance and how to move your body and how to play, because that is directly correlated to it from what I've if that helps.
Julian?
Yeah, well, first, thank you for the amazing presentation. I feel like that was really insightful as a soccer player to hear like how certain like factors weren't actually that big of a difference from turf to artificial grass. But that made me wonder even more, like, was there like more of a detailed description about the simulation exercise that the players went through? Because I know like based on what position you're playing on the field, like there's a lot of different like patterns of movement and like a lot of different movement entailed. And I feel like that would make recovery really different from player to player. So I wondered like how that was all like put into one exercise.
Yes, they had a couple of different exercises in the sense of the jumps and the passing and the way you move. But one thing that I also noticed as a limitation for this study is the fact that the simulation of a game day or of a game, it was very limited. As I even mentioned during the presentation, they didn't necessarily covered a couple of high impacts like a tackle or physical contact. They simulated a game, but not necessarily how a game would truly be in real life. Of course, if you're a forward, you might expect a couple things when you're playing. And as a defenseman, you're going to expect different ways of playing. As a midfielder is also different. Maybe a defenseman is not going to have such an impact when jumping as a forward if they're doing a sidekick or something like that. So I do think that they should have done a more in-depth when it came to the trying of the actual game, because those, as you said, it is different from player to player, not only uniquely, but also depending on their position. They didn't specify if the 12 players were all the exact same position or if they were 12 players that played different positions. But the fact that they did uniquely to each player, that might have helped with their conclusion. But I do believe that they could have done a more extent research when it comes to their position itself.
Okay, yeah, that answers my question.
Are there any other questions? Dr. Lopez?
Yeah, thanks a lot. Interesting study, and more importantly, that they actually have come up with a concrete decision that, it doesn't affect the turf, versus grass has no real effect on recovery. I think what happens is that, as Jack alluded to, injury rates may differ, but that also has limited literature out there on it. I think what happens is that most of the assumptions or the myths that have been out on whether, joint strain, muscle strains and things of that nature, or lower body non-contact injuries they came up with, these ideas have not been validated, right? So right now, this paper, and even though it had a small cohort, but they did 12 professional players. So I would assume that they standardized it, Hunter. So I think they probably made sure that they did it on probably appropriate fields, or maybe even allude to the fact that if they're professional players, they probably practiced and played on FIFA approved surfaces. Therefore, they could rule that out, or they maybe say that we assume that that was ruled out. But obviously, the biggest concern, I guess, between both surfaces is the cleat factor, the molded cleat factor, and turf shoes. We know that, playing on artificial surfaces or synthetic surfaces, it's a little harder if you wear molded cleats. That's why they recommended the turf shoes. They've moved in this with baseball with turf shoes. They moved into this now, where the infield is, artificial surface for practice, and you need kind of turf shoes to control your grip, versus, baseball cleats, or professional baseball cleats as well. The whole idea is that they've tried to mitigate the friction coefficient. That's what they're trying to get to, or what they're alluding to, right? That's that surface interaction, whether it's artificial, whether it's, did they talk about shoe wear in the study? They didn't, right?
No, they didn't, but I think that that is one of a very important limitation on the study, because the cleats are like very important when it comes to the turf, especially when you're transitioning from turf to turf, when you're playing in different places. Of course, there are other even important aspects of the place itself, but if I believe that if you already have a cleat that is good for a natural grass, or a cleat good for a artificial turf or a hybrid turf, that could go a long way in protecting the player and also helping with their recovery.
Yeah, I think that's a big point. Thank you for bringing that up. The issue is that the molded cleats, I don't know, Jack, when you play, do you play with our turf shoes, or do you play with cleats
Cleats.
for control and grip, right? So do you find that was harder with the molded cleats on the artificial surfaces versus the grass?
For me, it was harder on grass. I think especially like we practice on grass, but we played games on turf. But I feel like on grass, especially like when it's uneven and not well kept, it could just be like
Well, that may
cause
be
a lot of
just what
problems.
your resources
But
are, but you
yeah,
can imagine at the professional level, they've rectified that.
yeah. I don't
So
know. I
what I'm
personally
asking,
preferred turf. Yeah.
right? I'm just asking you though. Did you find feet soreness on the artificial surfaces
Yeah, to
with
some
the
extent, yeah.
molded cleats?
Yeah.
See, so I also felt that when I played. So I just think that there's still more to be done in this arena. So even though they did this, but I think it's a great step because you can now rule out, some of the myths. They've actually, quantified this with a good study that shows that, the soreness or recovery doesn't matter what surface you played on. And, it's always a big problem. Obviously, some folks were alluding to coefficient of surface, obviously practicing, without cleats on, barefoot, but that's impractical. Come on, you just get stepped on once with one of those molded cleats, forget about it. You're done for the week or two, you know? So again, there's some limitations, but I think they did a great job because when you just look at the literature that's out, it's very little. Did you find much literature on this topic or no?
When I was researching, I did not find that much regarding it. I feel like to the extent of this um, research, I feel like a lot of them are more of a literary or like a review article regarding a couple of things. And this paper actually popped up in a bunch of review article. So I think there's not that such an extent research in that area to the level of this article right now.
Okay, no worries. I appreciate the topic and good job there, Julia. I think what happens that this is, you know, a good paper because it concretely tried to quantitate the recovery process and whether there were challenges between the surfaces. Obviously, we're not talking about injuries, we're just talking about overall recovery from playing on the surfaces. So this is a good aspect to add in to our knowledge base about what's going on with the surfaces. All right. Any other questions?
Thank you so much, Julia. That was an amazing presentation. And thank you to everyone on this call, as well as everyone who asked questions. That will conclude week 5 of the RISE Institute and Rugby Research and Injury Prevention Group Sports Science Series. Thank you everyone for attending.